Hello, this is Mrs. Ward, and I'm going to go over the plane problem that was the homework, not the classwork. So you're looking at the one that says homework, and you have a plane traveling at 650 miles per hour, flying at a bearing of 130 degrees. There is a wind of 110 miles per hour at a bearing of 20 degrees. If no correction is made for the wind, what are the final bearing and ground speed of the plane? So the first thing it does is it tells me to draw a picture. So a plane has a bearing of 130 degrees. So remember bearings, this is 0 degrees, this is 90 degrees, this is 180 degrees. So since it has a bearing of 130 degrees, I know it's going to be somewhere in this quadrant here, and what normally is my fourth quadrant. So 130 degrees, I'm going to draw an angle like this, and this is going to be my plane. Now, I have to figure out the angle that I'm going to use in order to do this problem. The bearing from here to here is 130 degrees, but I want my trig angle. I don't want to use that bearing angle, so I have to figure out what that's going to be. So if this is 90 degrees of my angle, from here to here is 90, then the balance of that angle, what's left of that angle, this blue part of this angle, would be 130 minus 90, which would be 40 degrees. But since I'm moving down, going in a clockwise position, clockwise direction, and trig, that's considered a negative angle. So this is going to be a negative 40 degrees, because this 40 degrees plus this 90 degrees will give me that whole angle of 130 degrees. So when it says find the directional angle of the plane, I'm going to use negative 40 degrees. Now, if you change it to positive 320 degrees, that's the same thing, and that's perfectly fine. Now it wants me to find the coordinates of the plane. So I'm going to take 650, and I'm going to multiply it by the cosine of negative 40 degrees, sine of negative 40 degrees. Now, think about this. I'm in the fourth quadrant, so I'm expecting my x to be positive and my y to be negative. Any point in the fourth quadrant should have those characteristics. So if you don't get that when you multiply by the angle, your directional angle, then you know you've made a mistake. That's another way to check it. So when I take 650 times the cosine of negative 40, I get, I'm going to write it over here, I get 497.93. And when I take negative 650 times the sine of negative 40 degrees, I get a negative 417.81. So I'm happy because I have the positive and negative, and that's what I wanted for the fourth quadrant. The second part of the problem says that I have a wind of 110 miles per hour bearing. So I'm going to erase all these, get these out of my way so I can do my wind. That's not an eraser. So my wind is 110 miles per hour at a bearing of 20 degrees. So bearing of 20 degrees means going from north, as I move east, I am going to go 20 degrees. So from here to here is 20 degrees. But again, I want my trig angle. My trig angle is based off this x-axis, so I want this angle here. To find that angle, I'm going to take 90 minus 20, and I'm going to get 70 degrees. So the angle that I'm going to use for my wind is 70 degrees, and it's going about 110, so that would be this line here. So my plane I erased, but my plane was down here. Now I'm adding the wind, so I'm expecting my resultant to be somewhere in the middle here, probably in there somewhere. So now I have 70 degrees. Find the coordinates of the wind. So I'm going to take 110 because that's my speed, times the cosine of 70 degrees, sine of 70 degrees. Now that point's in the first quadrant, so when I multiply both of these, I'm expecting them to both be positive. And when I do that, I'm going to write those here. I get 37.62 and 103.37. Find the resultant. To find the resultant, I am going to add the 497 to the 37.62. And when I add those, I get 535.55. And then I'm going to add the negative 417 to the positive 103 and get negative 314.45. So that is my point. So my point is 535, negative 314. So it's here somewhere-ish. And then what are the final bearings and speed? So it wants the reference angle first. So to find the reference angle, I'm going to do the inverse tangent. And I'm going to do my B, which is the negative 314.45, and divide that by my A, which is 535.55. I'm doing that on my calculator. When I do that, when I put it in degrees, I get negative 30.42 degrees. So that's a trig angle. So this is my negative 30.42 degrees, and that's my reference angle. But now I need to find my bearing. To find my bearing, I want to start with, this is 0, this is 90. So I'm going to go 0, 90, this is positive direction, and then I'm going to have another 30 degrees. So I'm going to have 90 plus 30.42, and when I add those, I get 120.42 degrees. That's my bearing. I can leave it like that, or I can say to myself, well, that's one answer that I can give. The other answer is I can say, well, I'm going south. So this is going south, and then I veer to the east a little bit. So I can say south, east, and then I have to find this angle here. To find that angle there, I'm going to take 90 minus the 30.42. And when I do that, I get 59.58. So this would be 59.58. So south, 59.58 degrees east. Either one of these are fine. Your choice. Most people just stick to the 120.42. Then calculate the magnitude. To calculate the magnitude, that is the speed of the plane. I am going to take the square root of my A, which is 535.55 squared, plus my B, which is negative 314.45 squared. That. Make sure you put that in parentheses if you're using that negative sign so you don't make a mistake. And when I do that, I get 621.04. So the resultant magnitude is the speed of my plane, and that's going to be 621.04 miles per hour. The bearing from north is going to be 120.42 degrees. And then the resultant vector is at 535.55 and negative 314.45. Okay, I hope this helps, and we will see you.